All right. Hey, everyone. I'm Doman Jamek. I'm part of the AWS HealthOmics product management team, and I'm co-presenting with...
My name is Simon Valentine, CCO at Basepair.
Great. And so today we're going to talk a little bit about the opportunities that we've seen emerge within the biospace, some of the challenges that come with those opportunities, and then how Basepair and together with HealthOmics can help overcome those challenges. And then at the end, we do invite you all to come see us at the demo suite that we have. And so with the drop in sequencing cost and the emergence of all the different protocols, we're really seeing an explosion and a stepwise change in our understanding of biology. And that's changing things like agriculture, it's changing healthcare, and it's really accelerating kind of precision medicine as a whole. This deeper understanding is changing how we develop therapeutics. It's changing how we build tests for diagnostics. And also, how do we actually preventatively start addressing the total health of every individual? But with these technologies, there does come a number of challenges. First and foremost is just the size of the data. So I think I recently read we're at the exabyte level now with sequencing information. So it's starting to get huge. It's roughly doubling every year at this point in time. So it's starting to really strain all of the different resources that are involved. Additionally, the different protocols are causing specialization. You're having to get specialists to understand the data, the results that are being generalized or that are being generated. You're also needing to use specialized analysis tools based off of the protocol that you're using, the different types of sequencing, and how it's gluing. So it's really causing a strain on the people that are involved, but also the tools, because you can't necessarily grab one tool that you've been using, slightly say increase your sequencing depth, sequencing coverage, and then just reuse it because the statistics is likely to break. And then the third piece is there's really a lot of regulatory and compliance that are starting to come into play. So countries are getting very serious about health data protection, patient protection. And so this is leading to a whole wave of different policies that are emerging, different residency requirements. And then the administrators of these data sets are also having to deal with different levels of consent. So you're starting to get large data sets at a population level that have mixtures of consents, what can be used with different levels. And so all of this together is really straining the current compute infrastructures that we see, and really causing people to have to spend lots and lots of time on the IT, which is taking away from the science itself. And so we'll talk a bit about how you can buy a solution like Basepair and really solve those off the shelf, or use HealthOmics or the two together to build out that custom solution to really address all three of those areas.
Great. Thank you, Doman, for the opportunity to speak. Thank you, AWS, for inviting me to speak. It's a pleasure to be here. I think for those of you who don't know Basepair, I think I'd start just by sort of introducing you to the company. Essentially at Basepair, what we set out to do was to make bioinformatics easier, faster, and more cost predictable on AWS. That's our vision for the company. So at its core, it is focused on that. And it, from a visualization perspective, we try and be point and click. So our mantra is not about, oh, come and build a pipeline on the platform. Although you can do that, we find the bioinformaticians kind of know how to do that already, right? And this is more about once those custom workflows are ready to be shared and to be deployed, to be scaled, that's when you can use Basepair and its point and click graphical user interface together with interactive visualization to enable those workflows to be run and learned within about 10 or 15 minutes. So it's really all about ease of use. From a speed perspective, this is not advancing. Oh, there you go. From a speed perspective, you can use the inherent platform capabilities that are built in to abstract away the DevOps, together with drag and drop custom reporting capabilities to create new reports that really will accelerate the time to getting those workloads into production by as much as sort of eightfold. So taking it from, say, months down to sort of weeks. In addition, because we provision, the platform provisions in an organization's own cloud account, so they can use the storage and the compute resources that are there, we found that our customers can get up to about 50% cost savings versus, say, more traditional approaches. And it's, I think, really that unique combination of being pure SaaS, so ultra low operational burden, combined with provisioning in an organization's own account, that really delivers that cost predictability, the sort of IT governance that I think many organizations are sort of looking for. So who likes surprises? I do. If I'm having a party, I quite like a surprise, right? But I think the reality is that it's not for everyone, and it depends on the situation, right? Depends on the circumstances. I think if you're in the IT world, if this is going to work, going to move forward. Is it the green button supposed to be pressing it? Wait. Okay, maybe I'll hold it in my hand. I think if you're in the IT world, you don't want to be like this bomb disposal expert, right? You don't want surprises, right? You want more predictability in what you're doing. And so that creates a challenge, right? Because scientific creativity is sort of essential to advancing science. In fact, if you believe Edward de Bono, it's probably the most important human resource we have. And so the problem that exists is really that R&D programs can be unpredictable, right? So you have that sort of opposing situation. And creativity brings with it an element of the unknown, surprises. Indeed, there's probably no better example of that than the discovery of penicillin, right, by Alexander Fleming. And so to sort of balance out these two sort of juxtaposing forces, there needs to be a way of doing that. And so when it comes to building a solution to solve those two opposing problems, it's kind of a balancing act, right? It's quite hard to get right. So on the one hand, you need to think about the harder the more governance you put around something, the more control you put around something, the harder it is to be creative scientifically. And on the other side, if you're enabling a huge amount of scientific creativity, that's hard to then have some sort of control, some sort of predictability in the way that you're running things. So I think in an ideal world, whatever solution you choose to sort of scale omics analysis, thinking about those two juxtaposing forces, you probably need to think about something that fits in and around that sort of sweet spot that I have on that chart, right? But the reality is it's hard to do and hard to achieve and do it right. It's really a balancing act, right? So whatever solution you try and put in place when you're thinking about an infrastructure to help scale things, there are going to be a number of things and capabilities on the left that you probably need to be thinking about. Equally, you need to resource those, but at the same time, you need to resource those scientific creativity, those elements on the right, to be creative. And it becomes a balancing act. And as you scale omics analyses, you tend to find that those resources get dragged more towards the left. And you can really go about it solving this really in two ways. Like Bowman had mentioned, you either build a solution and you think about all these capabilities and you optimize them and you tie them all together, or you take a more platform approach. I don't think that we at Basepair would advocate for any one option or the other. I think it's really going to be dependent on individual circumstances. But if you do decide to take a platform approach, I think one would argue that you'd expect the platform to bring a lot of those things on the left, right? That's really what you're looking for a platform to be able to do, whilst facilitating what goes on the right. So for us at Basepair, we've spent many years, we've had dozens of conversations with individuals in biopharma and genomic technology companies, really to try and get a better understanding that if you're going to take the platform approach, what sort of things should you be looking out for? And this list I have on here is by no means exhaustive. I'm sure there are others, right? But what tended to happen was in those conversations, there were a number of things that just bubbled to the top. And we've tried to build those things into the platform. I think number one is, whilst it might have been acceptable 5 or 10 years ago to sort of upload your data to a hosted solution and move it around to get the benefits of a platform, we're seeing many, many more organizations now not wanting to do that. They want to keep the data secure in their own IT-approved cloud account in order to be able to do these types of analyses. And so our ability here at Basepair to be able to sort of deliver that unique combination of a SaaS approach but federating in an organization's own account means that you can take advantage of the economies of scale that you get with your cloud providers. It means you remain connected to all the other resources that you have there. I mean, no one platform is going to do everything. And of course, it means that you can have more control over IT governance, security, right the way through to sort of your cost, assumptions and commitments with your cloud provider. Number two is really around ease of use. So, one way of scaling this, of course, is to improve and optimize your IT infrastructure. But the other way is just to enable more people to be able to do the analysis, more scientists. And if you go down that route, you really have to think about user experience. You have to think about how do you make it super easy for someone to run an analysis and interactively visualize their data so they can understand that meaning. You can't have them sitting there learning a platform for 2 or 3 days because they're going to forget what they did next week. So for us, that's key. Ease of use. Third is, you might be quite surprised me standing up here as a software platform vendor, right? Talking about minimizing lock-in, but that's really important. No one knows what's going to happen in 3 or 5 years. What is everyone going to be doing? What's the right approach? And so for us, I think it's important that in any platform approach you take, it's got to be one that enables you to decouple the analysis from the platform and run it elsewhere if that's what you choose to do. It has to be something we feel that delivers somewhat independence over what workflow language the pipeline is built with. Who knows what the next flavor is going to be of workflow language in 5 years? I mean, not be anything that exists today, right? So it's these sort of things I think you need to think about when you're thinking about a commercial platform. Again, a little bit of an interesting topic, right? Pricing and licensing of a commercial platform. We would just argue that it needs to be clear and understandable. It can't be unpredictable. You can't be in a situation where you can't work it out. And it probably needs to support something that's low sample volume, so some sort of pay-as-you-go model, right? Equally, it needs to be very cost-effective as you scale it up. It has to meet both. And then finally, not for everyone in the room, but for those organizations working in genomic technology, they have an interest there in enabling their customers to be able to do that analysis. So maybe not so much internal R&D, but external. And so there you need to think about brand labeling. How do you keep customers in your own environment? How do you bundle analysis at the point of sale of that product in order to be able to get access to kit analytics and real-time usage and that sort of stuff? And so again, that's things that we think about at Basepair when we think about brand labeling and a business operations there that's based on coupons. So bringing all of that together in both of the last 2 slides, we've seen great adoption of the platform in multiple different areas, whether it be academia, whether it be genomic technology, so kit, diagnostic assay manufacturers, biopharma, right the way through into the clinical space. And then just finally, before I hand it back to Doman, the way that we decided, or the reason we decided to work with AWS and the HealthOmics services team is really because we feel that reinforces what we're all about. We feel that working with HealthOmics and integrating it into the platform allows us to be not just easy, but even easier, right? So even easier, even faster, even more cost predictable. So if you take the platform as a whole, encompassing those things, on the easy side of things, we're able to use our resources internally to focus on the capabilities of the platform that differentiate us, not on the more commoditized things that come with the platform. So we've been able to get new workflows to the platform in a matter of days, not weeks. On the faster side of things, there are actually some really cool capabilities within HealthOmics that allow our pipelines to run faster, just inherently. And then finally, from a cost predictability perspective, a managed service usually is more cost predictable, certainly when you're talking about running workflows and in certain conditions. And also, from a storage perspective, I think AWS has done a lot of good work to show that HealthOmics can deliver 30-40% cost savings, and that's what we've seen at Basepair as well, versus, say, S3 intelligent tiering. So with that, I'm going to pass it back to Doman, and he'll finish off and talk about HealthOmics. So thank you.
Thanks, Simon. Yeah, we're really excited about what Basepair is doing within the space and how they're enabling bioinformaticians, and excited that they were actually able to really get what our goal with HealthOmics was. So we launched HealthOmics with a goal to remove that undifferentiated heavy lifting that comes with building within this space, with meeting those challenges that we talked about earlier, and built it as a purpose-built service. So it takes a perspective view on the different tools that sit within AWS and helps deliver those to the bioinformaticians and to your broader company. And so within HealthOmics, we actually have 3 different components. On the file storage component, we have reference and sequence stores. These stores are built to house the different genomic files, to link them together, keep them organized within the metadata, tier them down, compress files that are not being used, pull them back out when you want to use them again, and deliver cost savings. All of this we do find can deliver 30-40% savings as a whole, and it does allow companies to deliver on the fair promise that everyone's trying to achieve with their data. On the workflows, we take away engine management, storage attachment to bioinformatics compute, and the compute orchestration also. So on the workflows, we do have a polyglot service. It supports CWL, WDL, and Nextflow. And it also has a set of ready-to-run workflows as well on top, which are workflows that are built by partners that are flat priced for the run. Alternatively, you can bring your own workflow definitions, bring your own containers, and it runs. And so we find that this piece really drives predictable cost and speed to production workflow runs. And then on variant and annotation stores, this is really when you're ready to go beyond the file, when you're ready to query, mix and match annotation information with variant information, slice it down into cohorts to share and analyze. And so this data we find is able to reduce data duplication, since it actually separates the annotation information into a separate store from the variant information, so that you store the variant once, you store your annotations, conversion your annotations, and then you glue them together as needed. And then all of this can plug into the broader multimodal analysis tools that AWS has, so that you can actually go beyond Omix and integrate in imaging, integrate in clinical records, integrate in telemetry, really integrate in anything that you want to co-analyze. And so this service is not static. We are constantly building. Because our goal is to remove that undifferentiated piece, that undifferentiated line keeps moving. The more we build, the more it moves. And so we're really investing heavily into interoperable data and workflow development. Last year, we stood on stage, announced 5 new features, and since then, we've done a number of different features and supplementary tools, including things like FedRAMP moderate support, semantic identity, linters that help you analyze your Nextflow and WDL runs to make sure that they conform without actually having to run them. And today, we're excited to announce that on the sequence stores, you can actually integrate them in with the broader S3 compatible ecosystem. And so sequence stores, when that reset is active, you get an S3 URI with reading capabilities. You can integrate it with tools like Direct Connect and CloudFront, or Mount Point if you want easier integration into reading them based off of your data integration. You can also connect it with tools like SageMaker if you're wanting to automatically train foundation models, pre-training or fine-tuning on top of data that's sitting in the sequence store. You can also directly integrate with your workflow engines. So all the different workflow engines that we've tested out, they all have S3 connectors out of the box. Having that S3 URI, you can just plug it in, whether it's running it within HealthOmics on the workflows themselves, or if you're managing your own workflow compute. And then also common industry tools. So tools that are built on top of SAM tools. They actually recently released a new version, 1.20. Highly recommend you go and check it out. But SAM tools and HTS lib-based tools all integrate in, as well as tools like IGV and other genome browsers. So we've really seen that a lot of our early partners have found a lot of quick utility out of this functionality. So Basepair that you heard from earlier, they were able to use this new feature to integrate the sequence store with their broad array of visual analysis tools in under a day of engineering time. Quilt recently, right before this, announced that they have a new version of their open source Quilt data catalog, and that was able to integrate in sequence stores due to this new feature. Clovertex has been helping companies deliver bioinformatics solutions, and they were able to integrate sequence store with all their different workflows and tools in minutes. And then Memverge is looking to integrate into their cost savings into different storage solutions. And they looked at sequence store and this new feature as one of those first areas of expanding into, and they've been able to integrate it with their workflow analysis already.